Space, vast, silent, and seemingly empty. When we look up at the night sky, we often marvel at the millions of stars and galaxies. But have you ever stopped to wonder why there's so much space between them? Why does it feel like the universe is mostly empty? Welcome back to Constantly Curious. Today we're going to explore a fundamental and intriguing question. Why is space so empty? The universe, as we understand it, is 93 billion light-years in diameter, but most of it is empty. And that's not by accident. It's the result of complex physics, cosmic evolution, and even the nature of gravity. Let's break it down. When we say space is empty, what are we really talking about? Let's use our own Milky Way galaxy as an example. While it's home to billions of stars, planets, asteroids, and comets, the vast majority of the space between these objects is nothing but emptiness, called a vacuum. But interestingly enough, it's not a true vacuum. Even in the emptiest regions of space, there's still a small number of particles, radiation, and dark energy present. So, when we say space is empty, what we mean is that it's incredibly sparse. The emptiness of space begins with the Big Bang, the event that started it all about 13.8 billion years ago. In the first moments, the universe was incredibly dense, with all matter and energy concentrated in an extremely small point. But then, space itself began expanding. Over time, this expansion spread out galaxies, stars, and other objects, leaving vast stretches of emptiness in between. Space didn't just expand outward, it also stretched the very fabric of space itself. This means that the distances between galaxies, stars, and other cosmic structures increased dramatically. As the universe expanded, objects moved further apart, and large empty regions, what we call cosmic voids, were created. These voids are not completely empty. In fact, they make up about 80% of the universe's volume. But the density of matter in these voids is very low compared to the dense star-filled regions of galaxies. Now, you might think, if space is mostly empty, what holds everything together? This is where things get really fascinating. Despite all the emptiness, the universe is not just a random scattering of objects. It's structured in a way that connects all of these distant stars, galaxies, and even dark matter. Imagine the universe as a giant web. In this cosmic web, galaxies are like nodes, and these nodes are connected by vast filaments of dark matter. These filaments stretch across the universe, linking galaxies together. They are the highways of the universe, where most of the matter and energy reside. Dark matter, an invisible and mysterious substance that doesn't emit light or energy, makes up about 27% of the universe's total mass. It's not directly visible, but scientists know it exists because of its gravitational effects on visible matter. The filaments formed by dark matter act as scaffolding, holding galaxies and clusters of galaxies in place. So, how does gravity play into all of this? Gravity is the force that attracts matter towards itself. It's what causes stars to form, galaxies to spin, and planets to orbit. In the dense regions of the universe, gravity is strong enough to pull objects together, but in the vast, empty spaces between these structures, gravity is weaker, and objects can remain separated. However, there's another force at work here: dark energy. This mysterious force is driving the accelerated expansion of the universe. While gravity tries to pull matter together, dark energy pushes everything apart. This balance between attraction and repulsion is what shapes the large-scale structure of the universe and contributes to the emptiness we see between galaxies. Let's go deeper into these cosmic voids. These voids are the largest known structures in the universe, stretching up to hundreds of millions of light-years across. They contain very few galaxies, stars, or other visible objects. But despite their emptiness, cosmic voids are not completely devoid of interest. These regions are home to some of the most intriguing phenomena, including the mysterious effects of dark energy and the behavior of matter in near-zero density environments. Void spaces are incredibly important for understanding the universe's large-scale structure. They show us just how much of the universe is empty and how the remaining matter is intricately distributed. Even in these empty expanses, scientists are constantly finding new clues about the origins and future of the cosmos. So, why is space so empty? The answer lies in the history of the universe's expansion, the role of gravity and dark energy, and the cosmic structures that connect everything. Space may seem vast and empty, but in reality, it's far from it. It's a dynamic, ever-changing system, where even the emptiest regions hold secrets that could shape our understanding of the universe for years to come. In the grand scheme of things, the emptiness we see is just one piece of a much larger puzzle, a puzzle that's still unfolding. Thanks for watching today's video. If you enjoyed this deep dive into the emptiness of space, make sure to hit that like button, subscribe for more curious content, and let us know in the comments what you think about the vastness of the universe. Until next time, stay curious.